Okay, what is this problem? This problem is set mismatch. What are we doing here? We are going to have a set of integers, and we have to find where there is a duplicate and the missing of that duplicate. So this is an example. The array we're going to get of numbers will not always be ordered or sorted, but we're going to have to find a way to find this number and its missing number, return that 1 1, so 2. This is a good example because you could come up with some pseudo logic where you're like, oh well, 2's a duplicate, so then 3. But this one, well, I guess in both these cases, the smaller number is, but a better case would be if this was just 2 and 2, and then your answer would actually be 2 and 1 here, and that's one of their test cases. So you got to think about this. There's a couple of brute force ways where you could just do like you search for this, and then I think you do a double for loop brute force. That'd be one way. Another way, common way, is just to create a hash map and create a hash of a map of how many you have and keeping that. But that's gonna be like O of n time and O of n space. And space is that you're now creating a map for each n of elements, and that's something that, what can we do better? In this solution I'm going to present is a bitwise solution. It's a bit manipulation, and I kind of like it just because it's not the best solution, but it's O of n and it's O of 1 space, but it is I like it just because it really, I learned a lot about XORing. And what we're doing here is we're using the fundamental fact that if you XOR 2 elements of the same, you get 0. And what we're going to see here is we're going to do like a combination of XORing, kind of extra XORing, to get a using this property. And so if we XOR the entire thing, the entire array of numbers, so if we go, what we will get if we do, naming convention here, L for element. If we do this, and this is, by the way, we just keep XORing, this would be the same as, technically, this may make more sense if we kind of knew, but this is actually faster because it's like a memory in place thing, at least in most languages. Actually, I can't say off the top of my head if that's 1000% sure for Python, but anyway, this is usually slightly faster. So what are we doing here? So if we do this for the entire array, what our leftover product is actually the XOR of everything except our except for our duplicate element and our element that we're also looking for. So we're looking for 2 elements, the duplicate and the one that is not represented because there's a duplicate. And so when we get this x is going to be that representation of all the numbers of 1 to n, but without those. And we can use that property now because if we XOR that number with all the elements of 1 to n, what we'll have then is a XOR of our duplicate and our other number we're looking for. And we could do this in one loop. And so I think originally I will do this to make it less confusing in a couple of loops, so it doesn't become too annoying. And we're just doing it from 1. These are 0 index, but we're doing it from 1 because we're doing it because it's a 1 to n. And so we want all of this, and this is not inclusive, so it doesn't include this number. So what we do here is XOR this, and then what we're going to do here is if we XOR these two, we have now our result of, like I just mentioned, this is the same right here, is just now having the XOR of our two numbers we're looking for. And now what we could do is, again, we're using properties of bit manipulation here, but the way XOR works is that it either is a, so if we have 0, 1 binary representation, and so this is 2 binary representation, this is 1 binary representation, XOR of this will equal this. Actually, that's 3, sorry. It's 3, and this will equal 2 because it's a OR exclusive. So it's only going to have this. Now, what does this tell us? That this tells us that this ones place, oh god, this ones place is the only place where there's a unique element here. Now, if we did like 0, 0, 1, 1, we'd still get the same answer. We'd still get this. But if we got this now, what do we have? We'd have 1, 1, 1. Now this could get tricky because we have a unique element coming from here, and we have a unique element coming from here. But we could use one of these digits to separate it and still use this XOR trick of XORing the duplicates. So here, this is what we're going to do. We're just going to use one of these digits, and how are we going to get one of those digits? Well, there's another trick we could do. Call this cancel. Cancel bit. And what we can do is we want that one bit, so we're going to use a AND here, which is going to, the AND operator only gives us the same bits, but we're going to use a complement -1, which will technically give us a right different bit. Yep. So we're right same bit. And I gotta plug in my computer. Yikes. Nothing to do. This will take 1 second. I love this computer. It's I bought it off of Craigslist for like, I think like $100, and it was just a cheap computer. It has 12 gigabytes of RAM, which probably is not that good in today's standards, but when I got it like 3 years ago, deal. My Linux computer, I love it. Anyway, so now we have this one bit, and now what we could do is we could do the same thing of now separating the two bits and using this like cancellation process. We can't, because we canceled it and we know which bit we're looking for, we could kind of use this cancellation of duplicates to percolate the bit, the number we're looking for with XOR. So now that we have cancel bit, Now the only issue is we don't know which one's the duplicate and which one's the missing number from doing this. And we have to loop one more time, which makes it not the most efficient time. Technically we do this in 3 loops, but we're going to do it in more than that. I could clean this up to make it in 3, but there's a faster way. Now we're going to do the same thing, but with indexes. And once we have this, we have the answers now. And now we could just go for a lot of loops here. Uh-oh. One of my indexes is off. Something's wrong here. Not sure what. One of my indentations is off. Uh-oh, I'm not sure where. I'm not seeing it if L equals cancel it. Alright, well, I'll run it and find the failure. For LNMs. This means the duplicate. Then we ans 1, ans 2, and then we can do if L equals ans 2, return the opposite. Alright, what did I do wrong? That's the issue. Oh, missing parenthesis. Nice. Where? Not here. Not here. And I think I might have messed this up. If I'm doing this, it should be 1 plus 1. And let's try that now. Alright, I think I got it. I did this earlier, you could see. This one's slower, because I did like 4 loops. You want to see it? I feel like I should leave that as is, and you could figure out as a user. Well, let's just do it, just for experimental sakes and practice sakes. So here we could obviously combine this. And what can we do here? Well, let's put this here. And we do I minus 1 there. We got rid of a loop here. And then let's clean this up because it's cancel bit. And then this, I believe we could mash into 1. With the same logic. And look at us go. There you go. Let's see if that runs. Yep, there we go. And that should be what we got. Memory should be good. Let's see, that ran in 300. This is not the most accurate test, but yeah, a little bit faster. There is a faster way. Totally different way of doing this, but that's what I want to cover. Is this kind of XOR magic. Well, that's what we'll call it, just XOR magic. A lot of extra typing. not probably the thing you would want to present on an interview, because there's a lot of ways it could go wrong. You got to keep some stuff in your head if you feel really comfortable. It's good to know, because like Zorin's a powerful aspect in terms of cryptography. It's a lot of cryptography. You could hide certain information by Zorin things, and then bring that information back by Zorin it again with your like kind of key, if you want to think about it that way. This is a problem I kind of was stumped on and worked out later, and I liked it. That's a wraps.